So let's get on a slant now.
Okay.
Because the whole cosine sine doesn't really make sense to me right now.
Okay. So if this were on a slant, so now we're gonna look at it like this sort of. So before the car was like this, it was driving forward,
Yes.
right, around the curve, and then it kind of goes like this eventually.
Mm-hmm.
So now, we're looking at the back of the car, and now this guy's on a slant, right? So now he's driving like this.
Right.
Okay, so let's draw a free body diagram for this thing.
Okay.
So what forces do we have on this?
So we have normal.
Okay, so you have normal.
Up, and we have gravity and the weight going down.
Yep. And so you'll notice, like the normal force is always going to be perpendicular to the surface it's on.
Yes.
And the gravity always goes down.
Right.
So when it's sitting on a flat surface, they balance each other out.
Mm-hmm.
But this time, not so much, right?
Definitely.
Yeah. So, okay. So what else do we have?
We have friction, keeping it from flying up.
Yep. We got friction.
And then it's going opposite of that.
And we also we're gonna have centripetal force, right?
Centripetal force, right?
Yep. And then here, so you'll notice when you do like slopes, and I think I talked about this in chapter 4, you have like a block sliding down or a skier or something like that.
Mm-hmm.
You want to tilt your XY axis, so now we have our X axis is here, and our Y axis is right here.
Okay.
So we're going to now we're going to look at each force. So this we want to put each force on either an X or Y axis. So this one's on Y and X. Yeah, sorry. Okay, so these forces are on the X axis, right?
Right.
And this one's directly on the Y. But this one, you'll notice, is kind of like, it's off. It's not really on either one.
Yeah.
So we want to break this one down and put it on an X and Y axis. So let me enlarge in this, put it over here. So we have, I don't know, pick an angle that this thing's at.
Let's do 19.
Okay, 19?
Yeah.
Okay, this thing's at 19. So now we look at this, so we have gravity. So we have mg. So we're going to have mg of y, and then mg of x. And so you can do the trig for this if you really want to, but the angle that the slope's at is going to be what this angle is right here, if we make this into a right triangle. So, in order to get these, so let's just go from this 19 degrees. Let's suppose I want to solve for what mgx is. How am I going to solve for that?
MGX, so we have, I don't know what we have right now. So you do cosine COA. So you cosine 19. MG,
Yeah.
MG cosine 19.
Yeah, okay, so we'll have
MGX over MG.
yeah, so for this side, we're going to do the opposite side, right?
Right.
So we're going to be using sine. Because sine is going to be the opposite side over the hypotenuse.
Right.
So in this case, we're going to have sine of 19.
You can erase all of that. I took a picture.
Okay, cool. I'm going to, let's just go ahead and erase this. Yeah, I'm going to write this up here. So we have sine of 19 is equal to the opposite side, right?
Right.
Which is mgx, over the hypotenuse, which is our mg.
Oh, that's the hypotenuse.
Yeah. So then from there, when we solve it out, we're going to get, so the x component of gravity is going to be sine of 19 times mg. So, does that make sense how we got
Yeah.
to there? Okay.
Yeah.
So you do the same thing for y. So this is going to be the adjacent side.
Right.
So it's going to be the cosine. So we can just say the cosine of 19 is going to be mg.
Okay.
Yeah.
Okay.
So how that changes the problem is basically now we do the exact same stuff except our normal force is not equal to mg anymore, but it's now equal to the force that's going to be opposite to it. So it's going to be equal to mgy.
Okay. Okay.
So we're gonna have something like this. So before we looked at like the net forces, right? So all the forces. So we had like we had our and it's okay. Let's just do this. Ma equals, and it's still gonna be 0, right?
Right.
Except this time we have an additional force. We still have our centripetal force pulling down, but now we have gravity pulling down too.
Mm-hmm.
So we're gonna have to add that. We're gonna have to take that into account. And then we have our friction. So friction now has to do more. It has to counteract both of those forces.
Yeah, the friction, is that pointing up the hill?
Yeah, it's pointing up.
Okay.
So you could. I just picked down. These were positive, and that was a negative.
For sure.
You could do it the other way too. You could say these are negative and that's positive. Either way, whatever you do, it's going to be 0.
Goes 0.
Yeah.
Okay.
So really now, instead of, remember before we figured out it was this, right? This
Yeah.
The centripetal force equal the frictional force.
Mm-hmm.
Well now, it's going to look like this. The centripetal force plus the x component of gravity, or this one, is going to equal our frictional force.
Fr plus mg. Okay.
Does that make sense?
Because they're both acting against it. So.
Yeah, so both of the ones going down have to be equal to that one going up, if it's 0, right?
Right.
Yep. So then from there, we can expand it, right? So we get m-ar plus mgx equals to the coefficient of static times normal force.
So Fr will always equal MAR. Can I say that?
This one?
Yes.
Yep. Yeah. So this is centripetal. So the centripetal force will always equal MAR. Frictional force will pretty much always equal coefficient of friction, static or kinetic, depending on what's going on, times normal force.
I see.
Mm-hmm.
I see. Okay.
Yep. So then we can just we can break it down even more, right? So we break that down, what the acceleration is.
Right.
Well, mgx is equal to the sine of 19 of mg, which we found earlier, right?
Mm-hmm.
Got our static friction coefficient. Normal force is equal to mgy, right?
Right.
And that makes sense, right? Because the normal force has to be acting whatever force is opposite to it. So it's acting just to the y part of mg, not to the whole thing anymore. So we can plug in this.
Cosine. Right.
And then from there, we could be solving for velocity if it wants it, the coefficient of static friction if it wants it, whatever we're trying to solve for, we can, find out what it is. So
That's terrific. Thank you.
yeah, so it gets a little messier when you start using like angles and stuff.
Yeah.
But really, if you just draw a free body diagram and break it down into x and y components and solve for it there, then when it comes to this, you just plug it in. You don't have to worry about, so cosine, is it sine, because you already found it. You just put it.
Yeah.
Yeah.
We just go so fast in class when you he describes how to do it.
Yeah.
And the process of why they do everything.
Yeah, I understand that. Yeah, like
Wow.
it just
okay.
goes way fast, huh?
This really makes sense though.
Yeah.
Yeah, it does.
Yep. So it gets kind of messy, but if you go slow and just kind of do the steps, and you go through this one, then you do that, then you do that. I mean, you can really once you get to this, then you can solve for anything that the problem asks. Really, I mean, it depends what it's saying, but like
Yeah. Yeah,
Yeah.
before today, I definitely had the block of how to get from the diagram to up to there.
Yeah.
And my orientation in my mind was always that MG was a right angle with MGX.
Oh, I see.
I
Yeah.
said flipped right
Yeah,
there.
that's what. Yeah, I've noticed some students will do that, but it's always going to be the y and x that form that.
Yeah.
You just have to think of it like a coordinate plane, so they all form 90-degree like angles, and this just depends on whatever that is. So know that like the mg and the mgy, the angle there is going to be whatever angle the slope's on. So that always makes it like easy too.
Okay.
So. Yep. And I mean, really, this could be, I mean, you could try to solve for the angle too. That could be one of the things it could ask for, like, so yeah, I mean, and if you go through other problems, you'll probably get practice with breaking it down. I'm sure in chapter 4 you had to do stuff like that too, with like blocks and